This next session is all about gamified research, and I've got two phenomenal researchers to talk to you about their successes with gamification. Starting with Lucy, whose face you can see now, I think, depending on how you've got your settings set up. But I'm going to start off by telling us a little bit more a history of gamification that we've been involved with over the last 10 years, and sort of identifying some situations where gamification can be really helpful. So, have you ever worried about data quality from distracted participants? How would you feel about online research or research generally if you were confident that you had your participants' whole attention? That's what we're going to be talking about in this session. How and when to gamify research so that you're confident you've got your participants' attention. Games are fun and engaging. They capture our attention and interest, and they keep us engaged in a task. Think about the card game Patience, or Solitaire, I think it's called sometimes. It's not much fun, but people play it for hours. Think about a jigsaw puzzle. Often when you deconstruct it, quite a tedious visual search task, really. And yet it's a multi-billion-dollar business. Well, probably not billion, multi-million-dollar business. People buy these jigsaw puzzles and they do them for fun. What if you could harness that degree of attention on your research tasks and collect all that wonderful behavioral data from kids, from adults, from everyone? How would that change your research? By the end of this session, you'll know when and how to create games like this Go No Go task, among many, many more designs. And it really is far easier than you might imagine. Hi, I'm Jo Evershed. I'm the founder, CEO of Gorilla Experiment Builder and the host of the Behavioral Science Online Conference. I've been helping researchers take their studies online since 2012. So I've seen a lot, and in that time, I've seen a lot of gamified research. Let's quickly have a look at the definition of a game. A game is a system in which players engage in a fictional challenge defined by rules, interactivity, and feedback, which results in a quantifiable outcome, often provoking an emotional response, an emotional reaction. In experimental tasks, we already do quite a lot of these things anyway. They're defined by rules, interactivity, we give feedback, there's a quantifiable outcome. So it's not a massive leap to gamify them. To take psychology tasks the rest of the way only involves adding a narrative and creating a positive emotional experience, rather than having our tasks feel like a chore. And let's face it, while the science is fascinating, auditory tasks or go-no-go tasks, executive function tasks, language tasks can often be quite boring for participants, forcing them to make two-way forced choice decisions quite often. Now, I grant you, these might not be brilliant games. That will be on the next PlayStation, but they are games. And if you want to read more about the taxonomy of games, I've put a link on the slide. Let's have a look at some case studies. I showed you this one a bit earlier, so I'm going to go through it quickly. I'm showing it because it's one of the rare case studies where we have before and after videos, and it has most of the components of a gamified research task. The left one is the lab version, the right one is the gamified version. Under the bonnet, they're exactly the same tasks. They're an N-armed bandit where you choose between slot machines or cards in the other one to try and find the one that pays out the most. The gamification techniques involved in this project here is you've got a simple narrative. You're in a casino, try to win, and that's signified by the cards and the lovely green card matting. You've got a score, which goes up when you get it right, and there's easy to understand and pleasing feedback, stars when you get it right and smoke when you get it wrong. Game elements are a lot of fun here. You get stars and fireworks when you win and a harsh buzzer and smoke when you don't. This made the game much more engaging and enjoyable for participants, which helped with recruitment. I would definitely use gamified tasks in the future. And this gets to the nub of why we want to consider using gamification. It's because it helps with recruitment. And we've seen earlier in the chat here that recruitment is often really hard. It's a big challenge for researchers. So when should you consider making a game? In this next section, I'd like you to think about whether you've had any of these research challenges, what impact gamification would have had on your data, or whether gamification would have enabled research that you have assumed was impossible. This was one of the very first games we created 10 years ago, before the Gorilla Gamebuilder existed, and it was for language research. This game was for Mairead McSweeney, who was looking at the relationship between speech reading skills and phonological awareness in young deaf children. With these games, children practice speech reading at the right right level of difficulty for them for 10 minutes a day for 12 weeks as part of an intervention design. The games made that a reasonable ask of children, their parents, and their teachers. So on this occasion, the games were useful for testing young children with limited language skills. The game teaches them what to do, and they find it naturally rewarding to succeed. And in return, RAID got their behavioral data. Let me give you an example of what a trial looks like. So there's a video that's playing, and you have to speech read what they're saying and understand the visemes. When you get it wrong, the alien vomits all over the place, which if you're 4, 5, 6-year-old is hilarious and will keep you playing for ages and ages. And when you get it right, you put helicopter into his mouth, he farts. And the farts change color on every trial, which is also wonderful if you're a young child. I think the method section of this paper must be hilarious to read, for what it's worth. Gamification can also help with dull, repetitive tasks. Unfortunately, not every task protocol can be rich and rewarding in itself. Some just aren't that fun. And as a result, we run into problems with participant engagement. Participants get tired, they get bored, attrition goes up, and so on. And you're left with noisy and low quality data. For these kinds of tasks, creating a fiction around what the player is doing and why can go a long way towards alleviating these problems. In this study, we created 8 different go-no-go tasks that kids completed 10 minutes a day for over 8 weeks. And overall, the kids completed around 4,000 trials of a boring go-no-go task and still reported enjoying the games, which I think is extraordinary. So whether you have a short dull protocol or a longitudinal dull protocol, games can keep your participants paying attention to your task. And as we know, good attention leads to good data quality. In this version, you have to inhibit when you see the dragon, and then when you inhibit, you get the gem. This is another nice one. This is a go-no-go task where there's a different picture coming in, which you have to ignore, and then you get the stimuli that you're meant to attend to, and then sometimes you're given a signal to inhibit, like that, and then you have to change how you behave. And these games were constantly adapting to the level of difficulty that the participants could manage in order to train their inhibition. Other times, our tasks are perfectly interesting, but our protocol is just long because we want to create learning. Learning often involves a lot of trials. We want our participants to do a lot of trials, and we want them to do it at the right level of difficulty for them, because we know that setting the level of difficulty at that sort of limit point is how we maximize learning. But we can end up with some of the same challenges: boredom, fatigue, attrition, and so on. This is where points and rewards can be effective. Rather than just doing trials over and over again, there is now a point to it, and crucially, a point to make progress to the end. So let's have a look at this trial. This was when you click on this button, you'd usually get an auditory signal, like put the wheel on top of the bat. And this game was for training children with developmental language disorder on these bits of grammar that they find really hard. So put the wheel above the bat or put the wheel below the bat. In this case, put the chicken below the bed, I think is the next trial. And when you get it wrong, it just doesn't work. So it's not making the child who's playing feel disappointed. It's just they get to try it again. And when they get it right, they get to go through and on into the next puzzle room. Finally, games can also be a great way of crowdsourcing data. With a little PR or advertising, you can collect a lot of data for free. See Hero Quest, which is this game up here from Hugo Spires, have recorded data from 4.3 million players who have played for a total of 117 years. Collecting 117 years worth of data via a recruitment service would cost in the region of £10 million. So that's a lot of research data. And Hugo didn't get it for free. He had to build a game to get it, but he got a really good return on investment there. Lucy Cheke, who you're about to hear from, has been collecting data on long COVID symptoms in kids. And Xander van der Linde has been using games to inoculate people against fake news and COVID misinformation. The important point here is that games aren't necessarily frivolous. They can be deeply serious in terms of the research value and in terms of the impact on the players. So another situation that benefits from games is when you want PR coverage to help with recruitment, or to have people, normally adults, volunteer their time and give you great data. So this is compelling. You get better data. So why haven't researchers done this before? Writing games historically has been really hard. You've had to write code, you need a developer, you need a game developer. This makes it too expensive, too slow to iterate, and too hard to reuse. And if you were using a tool like Unity, these are tools built for the games industry. You don't get the infrastructure, you don't get the precision timing needed for behavioral research. These are tools for games, not tools for gamified research. So we thought, could we do better? We wanted to keep all the benefits. We wanted to make it affordable to many, accessible to many, faster iterations, easier to reuse, longevity and open science, but as easy to use as PowerPoint. A bit later in this talk, Nick is going to show you behind the scenes on the Gorilla Gamebuilder. But first, Lucy and Katie are going to tell you about how they have used games in their research. So now, Lucy, over to you.
Hi, thanks, Joe. Can you hear me?
I can hear you, yes.
Let's try this. Right, can you see just my title screen?
Yes, I can just see your title screen.
Fantastic. Okay, thank you very much for inviting me to talk. So I'm going to talk about a couple of research projects we've been doing over the last couple of years, trying to introduce some gamification into cognitive research. So I'm going to tell you about two studies we've got running with using online games of quite different sorts, using quite different approaches to gamification. One using Gorilla Gamebuilder, which is new and shiny, and one using the Animal-AI environment, which is a sort of home-built thing that I'll tell you a little bit more about. Just a caveat before I start, I am not an expert on online research by any means or gamification. I'm just sharing some current research that we're doing, but I'm hoping that not only there might be some useful things for other people in here, but also maybe we can get some help from some of you guys. So the thing that I started off thinking with trying to gamify is that we need to meet kids. When we're talking about trying to do research with kids, we need to meet kids where they already are. Kids are playing computer games if they were allowed to get away with it all day, every day. If we want kids to engage with our research tasks, we can learn a lot from what they are spontaneously choosing to do with their time already. And so the first kind of subset I'm going to talk about is what I've called tablet tots. That is to say, very small children. And we're used to researching with very small children in the lab, because there's lots of reason, with kind of physical handleable tasks, because up until very recently, this is not a group, we're talking sort of 1 to 5 year olds. This is not a group that we can usually easily do computer tasks with. But with the advent of tablets, we now have, and proper tablets that they have at home all the time, not the old fashioned kind. We now have an opportunity to really exploit the kind of experience that young children now have. And again, I'm speaking here as a parent of small children. These are my two small children here, aged 2 and 4 in that picture, playing on their tablets, who would, if allowed, play tablets all day long. And what we can learn as a parent from just watching this is that there's a few things that, particularly for the younger kids, seem to be quite reassuring as would-be game developers. Firstly, these games are not sophisticated. They don't need a clever backstory. They don't need anything really fancy. Young children, 2, 3, 4 year olds have very simple tastes. Repetitive is fine. Repetitive is good. They like repetitive. They can't read. So many games on the tablets, let alone so many experiments, have text instructions. You need to have audio instructions. They will click on the most obvious thing on the screen, and they don't know gaming and internet conventions. If you have a symbol that universally means something, unless it's literally the play symbol with a triangle, they don't know what it means. And dexterity, for the young kids particularly, the dexterity isn't great. So dragging and dropping is fine for like 3.5 up, but my 2-year-old quite struggles with it. So I wanted to create a game that might allow us, particularly during the pandemic, to start testing really little kids online. And I came to Joe, or Gorilla generally, with my needs in that I cannot code, I have very little time, and I have very few resources. And Joe said, well, we've got this new thing. It's Gorilla Gamebuilder. And I promise you they're not paying me. But this was quite a find. So with Gorilla Gamebuilder, I'm sure that you're going to be taken through it in more detail, but basically you get a sort of screen like this, where you can you pick kind of create with Gamebuilder here, and then you build a screen with objects in the screen. You can move them around and create them clickable and so on. And then you have lots of different pages on the experiment, but then you can also kind of animate to change the nature of the what's on the screen as people go through the task. So I wanted to start very simple because I didn't know what I was doing. So I created a very simple visual search task. So this task, the pirate game, is a very simple visual search task. Essentially, you get given a target item. So you get the pirate and they say, please, can you find this? So this is a silver coin. And then after that, you get an array. So this is an example of a pop-out array. That is to say that the target is different from the notably different from the distractors. And so the idea is that this would sort of pop out at you. Or you can have what I've referred to as a camo array, which is where the items themselves don't stand out terribly well from the background and are quite similar to one another. And this involves a much more search effort. So what we varied here was set size, i.e. the number of distractors, the obviousness of the target, and the position. So I'm just going to show you a quick little video of what this task looks like. If someone could tell me whether or not the sound works on this, that would be really great. Could you hear that?
The sound isn't coming through to us.
Okay, the sound, the only thing with the sound is that all of the instructions are also read out as well as being
Lovely. That's such a nice thing to do for young kids.
So it says, can you find this? And then you have an array, and the child has to go and tap or click on the target. So these are the practice trials, and these are all nice, big, obvious targets. Let's get. So that's the end of the practice session, and then we have more trials, but just with much more varied stimuli. So these are kind of slightly obvious examples, and then you have these ones that are the really difficult ones. Okay. So that's the game. It's incredibly simple, and actually the gamification isn't great either in terms of my design, because we didn't do much in terms of like cool animations that happen when you get the right answer and so forth. And that was mostly because I was so short of time. I designed a whole animation to do, but I didn't have time to do it. But it's totally doable with the system. So I'm just going to show you a little bit about the kind of data quality and stuff of the data we've got so far. This is work in progress. We've so far only got 9 4 to 7-year-olds and 16 8 to 12-year-olds. This is, as Joe mentioned, a study on cognition in kids with long COVID, where we're testing those who have had COVID and those who have not had COVID. If you have a child aged 4 to 12, please feel free to sign up. We are still recruiting. You can just follow that QR code to do so, and I'll be at the end of the talk as well. So with it bearing in mind that this is work in progress, and I'm not going to show you the COVID, non-COVID data because the sample is too small for that so far. But what I wanted to check was to whether or not this was showing the right sort of patterns that we'd expect to see with a visual search task. So you can see here, this is you've got children, different age groups, and the performance in terms of reaction time and accuracy across these different levels of difficulty. So here we can see that, as you might expect, the more obvious the target, the quicker kids are and the more accurate. And that actually with the older kids, performance reaction time remained pretty steady, depending on how many distractors there were, but the younger children, that went up quite significantly. And this is what we were really looking for, this effect of the interaction between set size and pop out, which is something you really expect to see with a visual search task. So here we can see that when the target is obvious in the pop out condition, you see this flat reaction time. Whereas in the camo condition, when the item is quite subtly different from the distractors, you get an increase in reaction time as the set size increases. And that suggests we're picking up on the two kinds of visual search, the pop-out effect, where you just see it, and the serial, having to look at every single item in turn sort of effect. And that's really reassuring. The other thing I was looking for was a left-hand bias. We tend to have a left-hand bias in visual search, mostly because in English we read from left to right, and also because of the left-hand, right-hand brain issue that we're both mostly right-handed. And again, because I was able to dictate exactly where on the screen each of these coins were, and they each had a location, I can then map that. And I found that I've got this nice central to left-hand sided bias. So that was just an example of the first go I've had at doing things in Gamebuilder. I made a functional visual search task in about 2 weeks with no coding. We can put audio instructions on so the little kids don't have to read. It's playable on tablets, laptops, computers, and phones, but I opted out of that. And it was by far the most popular of all the tasks that were in that larger study that was part in. I'll definitely be making more tasks this way. And with more time, I think I can make something a lot better. But that's what I could make in less than 2 weeks, the time I had spare in 2 weeks, which I think says a lot. The other thing I'm going to talk to you through is the other kind of set of research that I've been doing in the last couple of years. And this is potentially for slightly older kids. Some cognitive abilities don't really lend themselves to be tested on this sort of 2D Tapler's style game that I've just showed you. These are better tested with games using embodiment or some form of embodiment, where you are a first-person individual exploring an environment, interacting with objects. And these are really popular with kids, as we can see with the popularity of games such as Minecraft and Fortnite. They're normally first-person shooters, but you don't actually, there's no law that says you have to have a gun in the game. So I want to introduce you to the Animal-AI environment. This is an environment created by a research team that I work with, created in Unity and originally designed to assess cognition in AI using tasks that are designed for testing cognition in animals, and that can be or have been physically implemented with animals and small children in real life. So to see kind of a little bit what it looks like, the aim of the game is to collect these green balls or yellow balls as well. So it's very simple aims: retrieve food, which are green or yellow balls, avoid poison, which are red balls, and avoid lava, which is a red or orange floor. And so we did a kind of a proof of concept study looking at comparing deep reinforcement learning AIs and 6 to 10-year-old children on a subset of the tasks that we presented in a competition, an AI competition a couple of years ago. There were 900 tasks in the original competition. Kids can't do it, 900 tasks. So we chose 40 tasks from 10 domains that kind of span the kind of simplest, kind of common sense kind of cognitive tasks that people do with animals. And this is Cosi Vuduris, who is my PhD student who did this work. So how do AIs compare to 6 to 10-year-olds? Well, a summary of the data is not well. Children outperformed AIs on everything. There was no significant difference between the age groups, but interestingly, experience with similar computer games did make a difference to the results. So that's just a thing to note, that if you are gamifying in a way that matches something kids might be doing, then they will have some expertise that will differentiate between different children. And Cosi did a cluster analysis showing that you could identify which individuals were AIs and which were children, regardless of the age of the child or the flavor of the AI. One thing we looked at particularly, for example, was object permanence. This is something that kids past the age of about 12 months in real life scenarios. We saw that with the agents, we could see that we can watch what they did. So not only look at their score, but watch what they did. And if you look back, not only do we know that, for example, the top agent only scored 25%, we know that they got that score by using the rule, always go left. And so actually, if we compared children to even the best AIs, children outperformed them on every single thing. There were one set of things that, for example, the children didn't do so well on. This is an example of a tool use task, and this is a 9-year-old who passed it. And we realized afterwards, and this is one of the importance of kind of doing these proof of concept and preliminary stuff, that these were just way too difficult. It sounds obvious to pull a hook to get a reward, but actually the physical manipulation of the hook was actually very difficult for children and AIs both. But what was interesting is that the difference between the children and the AIs was completely observable, even when both failed. So you can see it here on the left, an AI basically just going around in circles. whereas the child takes a really considered approach. We can watch back exactly what the child did. And then through different ways of coding the data, we can start to get maps of not just performance, but of pattern of performance and type of behavior. We're taking this forward with the Animal-AI environment. Firstly, I'm working on some particularly large batteries. So Cosy's working on an object permanence battery, and this is Denia, who's working on a space and object hood battery. We're also working on new features. So we're building in reward dispensers, which are these, ripening and decaying rewards, and new playable characters to make it cuter and funner. So we're basically trying to make it more versatile and attractive. It is currently available for other researchers to use online, but it's really tricky and fiddly at the moment. So we're trying to work on making it more available as well. And so to this end, we will be hiring someone. So please do watch this space. And if you've got game dev experience, particularly with Unity and putting things online, get in touch. And the point of this, I realize I'm running out of time, but the point of this particular approach is that we're really trying to build this for translational potential. The Animal-AI tasks are designed to be, because they're in this kind of physical environment that could be real, it could be a room in a lab. They are playable as computer games, yes, but they are directly related to those tasks that can and are used physically in the lab, both with animals and children. So this facilitates translation between animal models, lab work with babies, toddlers, children too young for computers, online games for older kids and adults, and computational models, because remember, this was designed for and is being used for assessing AI models. So we can make computational models of cognition, of impairment, of development, and directly test theoretical accounts, all within the same environment. So to summarize, Einstein apparently said that having fun is the best way to learn. Having fun is, I think, also the best way to test what has been learnt. And I'm certainly going to be moving more towards gamification in everything I do from now on. So just a quick thank you to the many people that have been involved in both of those research projects. And thank you to Gorilla and to Joe for inviting me to speak today. If you want to take part in want to try out the pirate game on your own kid, you can follow this link down here at the bottom here, or scan this QR code and it'll take you to the recruitment site. Thank you very much.
Thank you, Lucy. That was amazing. I'm going to ask the audience in the chat to put any questions you have for Lucy into the Q&A now, so that I can come back to those in a minute. I'm just trying to think what I want to ask you. I actually just find that also fascinating. What I don't understand is, how have you been able to do all of this? You're like a mum, you've got two kids at about the same age as mine.
Okay, so I did the visual search task, and that was mostly because with the COVID project, it's funny, I have two hats on. I am a researcher in the psychology department doing the effect of kind of health on memory and cognition, and that basically has no funding and is running on volunteers and students and like me trying to do stuff myself. And then I'm also I work in an AI institute called the Centre for the Future of Intelligence, and there I'm the director of the Kinds of Intelligence project, and we've got multiple incredibly talented postdocs doing amazing things and PhD students as well. So I like that. This is well resourced, this is not. So on this side, I did the game builder thing myself because I didn't think it was fair to expect anyone else to kind of work out this new tool. There is a moth on my face. And with the Animal-AI thing that's being developed with, it's mostly funded by people who are very interested in understanding the cognitive abilities of AIs at the moment, which is a big deal for for economic, policy, security, and so forth reasons. But I'm keeping it so that it can still test kids, so that we can bring it more further into psychology. And I'd really love to build a community around people using this to test kids, because I think it has loads of potential. But yeah, there's a big team.
So that's amazing. I totally agree with you. I think the idea that AIs are going to reach adult level cognition without first developing childlike cognition is unlikely, and the data
they need rat-like cognition
first, right? Yeah. And so we're going to have to work this way back and layer them in. And that was so interesting to see how the AIs were performing against, what was it, 6-year-olds?
6 to 10-year-olds,
to 10-year-olds, and still very basic. But if we can get that data from younger children, that's going to help that journey. But of course, at the moment, you can't get younger children to do this task online. They're too complicated. But if we can simplify them, then we might be able to start getting to a point where the AI can outperform a very young child
Yeah,
if we're confident they're using the controls. So I think that's tremendously interesting. Question has come in. Thank you. Do you ever allow adults to play with their kids, e.g., as a fun activity to do together? Because then adults could try to encourage kids to beat them.
That's a good point. It's a good idea. We haven't done that. With the pirate game, I'm not sure how. I mean, yeah, there's the practice trials and so on. But I think with Game Builder, you probably could. Yeah. With Animal-AI, certainly, like we had practice trials, and it's very open, which is why it takes actually a lot of skill and developer time. So it's currently tricky. But we had in the study that we ran, we had children requesting to be able to come back and just keep playing and messing around with it. And so we had to kind of have a two-tier system, like we're collecting data from you versus like you've come back for the 16th time and are trying to beat your own record. So definitely there was lots of scope for that. And the tasks we were doing were boring for adults, but that's because it was really like, here's a reward, can you get it? But they don't need to be boring for adults. And we've made some really hard ones now. So hopefully we should be, when we are planning on testing adults as well. So I think that's a really great idea of engaging kids.
Yeah, and if you were using Gorilla Game Builder, there are two ways you could do that. You could have like, now the grown-up has a go and now the child has a go. So you could interleave them. That could work really well. Or we do have multiplayer coming to Gorilla. So you could set up so that a parent and a child could in fact play together and respond to the same task. I guess the bit that's always tricky there is you don't want the parents coaching the child, because you actually want to genuinely capture the child's behavior. That's always the tricky bit to compensate for. I hope I have tweeted your link that you need more participants. If anybody on the call today has got young children, please do consider reaching out to Lucy. There was another question from an anonymous attendee. Are you open to people reaching out to you to discuss your research?
Yes, of course.
Is the best thing to do find you on Twitter and then take it from there?
Yeah, probably. So I'm at Lucy Cheke on Twitter, very straightforward. Just my name, but with no spaces. So yeah, absolutely, please do.
Perfect. Excellent. Next, we're going to go to Katie Mansfield to share her research. Katie, welcome. Thank you for joining us today.
How are you?
Very well. Yes. So, do you want to share your slides?
Yes, let me get them up. Hopefully this goes smoothly. Just bear with me a second. Can you guys see that?
Yes.
Perfect. Yeah, so
working.
Yeah, so shall I begin?
Yeah, off you go. That's all working fine.
Perfect. Yeah, so hi everybody, I'm Katie Mansfield. I'm a PhD researcher at the University of Sheffield, currently in my second year. If you haven't guessed already from the front sort of picture on my first slide, and sort of the text, obviously, my research lies at the interface of linguistics, education and psychology. So it's a kind of broad mix of all of them. My background is in linguistics, but psychology and education have always been things that I'm interested in. Yeah, so my talk today is all about working memory and executive functioning, and however that plays a role in the use of standard English in working class children's speech. So we'll begin. Yeah, so just to provide a brief outline of what I'll touch upon today. So just a brief overview of my research, just to contextualize the game that I created using the Gorilla Gamebuilder, just a bit about gamifying psychological tasks. Then I'll show you some quick snapshots and a quick video of the game that I built using the new Gorilla Gamebuilder. And then we'll just touch upon some preliminary observations that I got from doing the task with the children. So just a background to my study, where do working memory and executive function sort of fit into all this then? How does it fit in with this linguistics stuff? So it all starts really with the national curriculum in England. What the national curriculum stipulates is that all pupils should be taught to speak clearly and convey their ideas confidently using standard English. One of the main criticisms of that, though, is whether it is technically realistic to expect children to use standard English in these really disparate contexts, where informal situations and informal contexts. Research has consistently shown in linguistics that informal contexts favour the use of local vernacular, and by vernacular what I mean is sort of local dialect, For instance, so I'm from Leicester, so the local dialect to Leicester, basically. And it assumes that all pupils will be willing to change their way of talking for another and be able to manage and control different language styles. So what it doesn't take into account is this kind of cognitive dimension of this style shifting, the shifting between the local dialect and standard English. It doesn't take into that context, that kind of idea. And also with social class as well, if we touch upon this, working class children, if we compare working class children to middle class children, working class children, the majority of them will be local dialect speakers. And obviously from this requirement in the national curriculum, they'll be expected to switch the local dialect forms that they habitually use for standard English ones in order to succeed at school. And managing this mismatch between the variety that they use at home with their family, with their friends, and that expected of them at school, whilst also having to complete the intellectually demanding tasks that the teacher set for them in the classroom, what this could potentially do is impact upon their processing capacities. If we look at it from a middle class perspective, middle class children, many of them enter the classroom speaking standard English. So therefore they don't bear the same burden. They come from this background where speaking standard English is the norm. So they don't have that same sort of cognitive burden that the working class children would. So the questions that I seek to answer is there a potential interaction between children's working memory capacity and executive functioning and their style shifting abilities? And are working class children placed under increased and inequitable cognitive load in the classroom because of the requirement that they use a language style which is less routine for them? So gamifying psychological tasks then. So if we move on to this, so there's three psychological sort of abilities that I will be testing, that I've tested through the tasks. And these are working memory capacity, shifting ability, and inhibitory control. Typically, these are measured using quite traditional psychological tests, often by pen and paper or through programming software, which is specially designed for the running of psychological experiments. Examples of this could be SciToolkit, for instance, which is particularly good for these traditional experiments. The problems with this, though, is that it's effortful, it's frustrating, and it's repetitive for the children. So what they find is that it's quite boring, that they can't sort of engage with it. So it leads to participant disengagement and therefore poor data quality. This is where the Gorilla Gamebuilder comes into play. So I came across this through my supervisor, who's a sort of expert. She works in the psychology department at Sheffield. And yeah. Yeah, 1 second. 1 second, we're just moving rooms.
Katie, don't worry about it at all. I know these things are stressful, but everyone's here with you, and what you were saying was absolutely fascinating.
Thank you.
No, you're very welcome.
Okay.
If anyone's,
let's get back to it.
Yeah, let's get back to it.
Yeah. This is the nightmare of working in a school.
Absolutely. You're doing absolutely great. Everyone is fine and patient and eager to hear what you have to say next when you're ready for us.
Okay, so this is where it kind of leads on then to the Gorilla Gamebuilder. I was introduced to this from my psychologist supervisor at Sheffield, who she's got quite lots of experience working with Gorilla, quite well trained in it. Something I've never heard of Gorilla before, so it's all completely new to me. But I was intrigued to kind of look at the possibilities that it could offer to my research. So yeah, so just to sort of introduce the Gamebuilder to those who have not heard of it before, it's a new state-of-the-art tool which allows you to go beyond traditional lab-based work. The new Gamebuilder tool allows researchers to create interactive games like the one I'll show you in a moment, which turns formal and often repetitive psychology tasks into quite an exciting activity that children actually really enjoy doing. There's no coding or programming knowledge needed, which was an absolute dream for me because I hate coding. And it boosts participant motivation and engagement without compromising data quality, which was another big advantage for me that kind of drew me to want to use the Gorilla Gamebuilder. So just to show you, to give you a brief sort of snapshot of the video that I created. Unfortunately, the sound is not working for some reason. I'm not entirely sure why, but this is just a snapshot of the first part of the game that I created. As you can see, there's loads of different stuff. The capabilities of the game builder is absolutely brilliant. You can make it as interactive as you want it. Basically, there's you can't see it now, but there's background music, there's audio clips you can upload. You can bring your characters to life, basically, to really add that extra sort of engagement with the children. So this is all, you can have your own backstory. So this is all about a burglar stealing puppies, and the children had to retrieve the keys to unlock the puppies. So that's like the backstory to this game. So there's 3 tasks, and they had to basically win a key for each task to unlock each of the puppies. And the keys were all hidden in this burglar's kind of like warehouse where he was storing all his stolen stuff. So yeah, as you can see, there's you can animate text, you can animate speech bubbles, you can have as many characters as you want, you can have any background as you want. The capabilities of this is literally endless. The more that you play around with it, the more exciting it gets. So yeah, that's just basically the sort of start of the game, how I set that up. So just to take you through the tasks that I had. So obviously I was talking about measuring working memory capacity. To measure working memory capacity, what I did was a running memory span, which is a psychology sort of test of working memory capacity. Basically what it involves is a list of numbers is read out to the participant, and it will end unpredictably. So the child will not know when it will end. And then what it will ask the participant to do is recall as many of the last items in the list as possible. But the catch is it has to be in order. This is actually a really good test of working memory capacity. As you can see, the way I sort of integrated that into the game is through a safe. So what I did was told the children that the key was in the safe. They had the audio clip would play on the in the children's headphones, and what they had to do was enter the code into the safe and click on this blue save button here to turn the safe and see if it would work. Obviously it was set to have so many trials until the game ended, obviously, but they enjoyed this kind of, instead of it being like a repetitive task, which it would have been had we not had this sort of interactive nature, they enjoyed keep trying the lock to see if it would work, and that was what really sort of engaged them in this task. And then the shifting ability. So yeah, to do this, the shifting ability is basically a participant's ability to shift from one category to another category. And to do this, I employed the colour shape task, which is quite notoriously used to test this ability in the literature. And it's had quite successful results. The colour shape task, then, what it does, it tests shifting ability, and by that it means how participants can resolve interference. So can they actively switch from the one rule of categorizing something to another? So in this case, what we had was a colour task. So Superman was with the colours, with the shape, and Wonder Woman was with the colours, and they had to categorize them by whether it was a circle or square. And when it was Wonder Woman's turn, they had to categorize them as whether it was yellow or blue. And in here, this is when we could, so these were all single trials. So it was 3 blocks. So we had a shape block, colour block. Here we had the switching block as the 3rd block of trials. And what the children had to do, if I just play you this just to show you what it looks like, the fixation point would appear, and wherever the shape, whichever side it appeared on was which rule the children had to categorize by. So if the circle appeared, for instance, on Superman's side, they would automatically know then that they had to categorize by shape. If a square appeared on Wonder Woman's side, then they would have to categorize by color. What I did with this data is I'm currently in the process of collecting all of the data, and we'll be calculating reaction time and percentage of correct responses, which brings me on to another point with the Gorilla Gamebuilder, what's brilliant about it is that it does it all automatically for you. You'll get a spreadsheet with all the data on, and it shows you the reaction times from participants, the accuracy. You can set up scorers, all sorts of things behind the scenes that enables this data to be collected like automatically, and it's brilliant. Obviously, it avoids the possibility of manual error as well, which is brilliant. Another advantage of it. And then the last task that I did was inhibitory. It was testing inhibitory control. And one of the most used tasks for this in psychology is the go, no go task. What I did was employ 2 blocks of 50 trials. And essentially what the go, no go task does, for people that don't know what it is, essentially it's a task where the child builds up this response. So in this case, we had blue diamonds and purple diamonds. The children had to press the space bar every time they saw the blue diamond. And then because they build up this automatic response where they're expecting a blue diamond, when a purple diamond appeared on the screen, they had to control themselves and stop themselves from pressing the space bar for the purple. So yes, that's how it kind of tests inhibitory control. So 2 blocks of 50 trials. And again, I'm currently working through collecting the rest of the data for this, and we'll be looking at reaction time and accuracy. Just to show you a quick video of how this one works. So again, we have a fixation point if it wants to play. I don't know if it's going to work. Yeah, so we have a fixation point and then the diamond will appear, and the children have to react accordingly. Just some observations then to finish off with, because obviously I've not got any sort of data to present, unfortunately, today. In terms of things that I've noticed whilst carrying out the game with the children, the first one, no reduction in data quality. I think that's one of the biggest things for researchers like yourselves who are probably interested in potentially using a game builder like this. The concern I definitely had at the beginning was whether there would be a reduction in the data quality from, like, obviously gamifying something. Would it alter the quality of the data I'd be able to collect? And it hasn't. And the second biggest thing for me was participant engagement. So particularly what I noticed was, obviously in an average class, you always get some children who possibly don't really have the best attention spans. They probably have lower attention spans than other children. And what I noticed was the children that I was particularly concerned about doing the task with, whether they'd be able to sit in one sitting and complete the game, were the ones that I shouldn't have worried about at all. They sat down, they were completely enthralled by the game. They thought it was great. They just wanted to it brings me on to my next point. They just wanted to complete the game again and again and again in their free time. I've had the children coming up to me whilst I've been working at the school for the last couple of weeks since we've been doing the game, and they've been saying, "Oh, can we do the game today? Can we play the game again today? I want to beat my score." So that just kind of tells you all you need to know really about this participant engagement and how gamifying something that would be traditionally quite boring, quite repetitive, actually can be made into something that a child would enjoy. And just the next step really in terms of how I'll be linking this data to the rest of my project that I'm doing. I'll be doing a speech-based experiment. This is more of the linguistic based stuff. And what it's designed to do is induce varying levels of cognitive load. It basically has a reading and comprehension task that's set as the control task. And then it's got 4 different conditions, as you can see. So different demands are placed on the children. So you've got whether they'll be told to speak in their home language, whether they'll be told to speak in their school language. And in these 2 conditions, whether they'll be in these 2 conditions, 2 and 4, whether there'll be an additional task they have to complete, which will be an auditory based task, as well as the comprehension task. And what I'll be doing is trying to draw some correlations between the data that's collected from the Gorilla game that I've created and this speech-based experiment data to find out whether the children's working memory and executive function scores are related to their performance in the speech-based experiment, and start to explore those potential implications for educational policy and practice. That's me finished. Thank you for listening, and thank you for putting up with my minor pause while I had to change room. I've included my Twitter handle here just for anybody who's interested in my research or interested in how I went about building the game, and could potentially be interested in doing that themselves. So yeah, you can catch any updates on my PhD on Twitter. Hopefully there'll be some highlights and stuff of my data soon. So thanks for listening, and I'll be happy to take any questions.
Katie, that was phenomenal. While people are putting their thoughts together into questions in the Q&A, I just wanted to say, if you were my PhD student, I'd be tremendously proud. That's a phenomenal amount of work you've done. It's extraordinarily difficult doing work with kids in schools, psychological, and you're managing to clearly juggle a very diverse set of work, and you're doing it with tremendous grace. Well done. If anybody does have any questions for Katie, please put them into the Q&A. That would be really interesting. You're getting lots of positive feedback here. Is that
we've got my
supervisor? Lots of people saying it's very interesting work and what a great approach. It's one of the things we've heard a lot from researchers like you as well, the capacity to go and test kids with special needs with the Gamified tool is just completely transformative. And there are so many parents and carers and teachers out there who actually have very weak understanding of what the children with special needs are able to do where they are at the moment. And if you could get decent measures and then be able to track them over time, because you could send that game off to them, then that would be a tremendous benefit. There's a question here from Kimberly Beaumont. Amazing talk, Katie. Just curious, how were the children responding in the switch task? Different buttons for the circle, square versus the red, blue. Like, what were the controls here?
So for the color shape task, so in the game builder, it's really clever how you can set it up. So you can set up a keyboard response. So the way this particular task was set up is if the children were responding to they obviously had the single trials, the color trial and the shape trial. So in the shape trial, if a circle appeared on the screen, they would press screen, they would press the J key. Then what would happen in the next trial for the colors, they would press F if the shape was yellow, and it completely ignore the shape, just looking at the color this time, and they would press J if it was blue. And then obviously we've got this thing, because they've learned two different rules, can they switch between those rules in the mixed, obviously the switching block of the trials, where depending on which side it appears, can they automatically retrieve that rule that they've learned and know whether it's going to be obviously the J key or the F key. It was quite a tricky one, to be honest. It was quite tricky for them to get going with it. Once they had the practice trials, because I did include some practice trials, I should have mentioned that, just to get them familiarized with the sort of the concept, what they were meant to be doing. They flew through it. They were absolutely fine. So it was really nice to see how much they enjoyed just playing around with it. Because I was really worried to start, because this is something quite new to me. I'm not, as my supervisor will probably tell you, I'm not in any way familiar with Gorilla. It's been something completely new from scratch to me that I've had to do. And going back to December when I first started, I was having an absolute meltdown thinking, I'm not going to be able to do this. There's so many different buttons. There's so many different capabilities that this piece of software offers. I don't even know where to start. So I took some time away, and I'm so glad. I say to everyone at the university now, I'm so glad that I didn't just walk away from the game builder and actually got the license and sat and persevered with it, because it was one of the best things that I've done in my PhD. It's really helped me to take this different approach, to take this different perspective, and actually produce something of this quality. I never thought that I'd be able to produce something like this, that collects the data in such just an efficient way. Like the way the data is coming out in the spreadsheet at the moment, it's brilliant. It's so easy. And as I said in my talk, it just avoids these problems of manual errors that's so many of us, when we've got so much work to do, it's so easy to just make these silly errors that you don't even realize you've done. And by the Gorilla, it just simplifies so much stuff for you. It's brilliant. Yeah, it's absolutely brilliant.
Well, that's fantastic. And I'm so glad you persevered as well, because I think what you've managed to create here is truly impressive. Nick is now going to give his presentation showing our assembled company here today some of the functionality of the game builder and how it gets put together. And indeed, he will be saying, don't worry about the UI. It looks confusing the first time, but once you work out how it works, it does become simpler. Katie, have you found that it has got easier over time now you know what you're doing?
Yes, and just as a side note before you pass on to Nick, if anybody's interested in the game builder, Nick and his one of the support team, Claudia, are the most helpful people when you've got issues that you're falling into. I think I've had several one-to-one meetings where I've just been having a breakdown thinking, I don't know how to fix this. And it was something so simple. And the support team at Gorilla are so nice, and they'll go out the way to help you and not just do it for you. What they do is they break it down step by step. So then you're able to then apply that yourself to the rest of the tasks. And without them, I don't think I'd have been able to create this game, to be honest. Without them and my supervisor, I wouldn't have this to show you today.
Oh, I'm really glad we could help you, Katie. So Nick, over to you. Do you want to share your screen?
Yes, let's do it. All right. Okay, hello again, everyone. Can you see my slides and hear me? I'm going to take the lack of terrified yelling from the rest of my team that you can. All right, fantastic. So thank you so much, Katie. That was a wonderful talk. And it's certainly really gratifying for me to see these things actually come together and be made flesh, and then actually go out there and actually be collecting data in the wild. That's just super exciting. So you've seen quite a few games now, both the wonderful examples that Katie and Lucy have done and the demos that Joe showed you earlier. And as several of you were saying, if any of you are thinking that, oh, this looks quite complicated, I don't think I'd be able to do that, don't worry. I'm going to show you how the game builder works, and also I'm going to show you how some of those different effects are created. I should warn you that this will completely ruin games for you, as these things are a bit like a magic trick. Once you know how it's done, you can't unsee it, and it's all smoke and mirrors, and you'll see how this is done in a bit. So to start off, so when we came to design the game board, obviously we were making games for research for quite a long time, as Jay said earlier, and we knew we wanted to build a tool to let people do this themselves. It was no good us just building all these things bespoke each time. And well, the main sort of guiding principle that we wanted is, first of all, this needs to be easy and accessible to put together, and the sort of rough bar that we kind of set ourselves, we want this to be about as easy as PowerPoint to put together. You saw Unity earlier that Lucy's team have been using, which is a fantastic engine, but it's big and complicated, and it takes a lot of stuff to put stuff together. I'm a great fan of Unity. I've built stuff in Unity before, but it's not quick and simple to put things together. And the other bit, which again you saw in both of the talks earlier, is that we are making games for research. We're making research games, not just games. And obviously, but we want some game-like stuff in there. So we actually need two things here. We need the core trial engine underneath it. So we need reaction times, we need response processing, we need proper trial structure, and all of the randomization and controls that go with that. And you saw that in both the talks earlier. We still need all of the kind of stuff we're essentially used to when we're building our sort of mainline reaction time tasks, but we want this game tech on top. We want this particle engine on top, and we want this animation system on top. And it's the two together that's how Game Builder kind of comes together to give you all of the systems that you need, but with all of the experimental power that you need in order to actually do research with it. So the first core bit, as people said, is the animation system. So I'm going to show you a bit about what this looks like. So here we are. I've got a rabbit, and I've got set up a simple animation sequence that just shows a whole bunch of the different animations in the system. So if I just play it here, we can see that you can make him bounce up and down, you can make it scale come down, you can make it spin, you make it fade in and out, and so on. Now you edit these animations in the animation tool. So I can go in here, I can pull out my sequence, and you can see there all of the animations that we put in there. You can add new ones. We've got a big list of all the different kind of effects you could put in there, and you can just click on each one to edit its settings. If you want to reorder them, you can just drag them around. So if I wanted the spin to happen first, I could put this up there, play my animation again, and now you see the spin happens first. And this, like I said, this is very much modeled on the animation pane in PowerPoint, which is nice and super easy just to put things in there and reorder them. So just using animations, I want to show you what you can create. Now, I'm going to show you a task now, and I'll explain what's going on, and then we'll see how the animations are put together. So here we go. In this game, you are a rabbit. There are two trees, and you want to press left if the apple is on the left, and right if the apple is on the right. But you need to watch out for the crafty fox. If you get it wrong, the rabbit says, no, I don't want to go. There's no apple there. And You see this one's got the fox on there, so we managed to avoid that. And this one's got a confound, got an apple in both tree, got a fox on the left. And if I go for that one, it's going to say, hey, no, there's a fox there. I'm not going there. So that's that task. Let's go. I'm going to show it to you again, and we're going to just call out the animations that are happening. Okay, so that's a move. There's a shake on the little branches, and the apple appears and moves up. The rabbit goes in, the apple falls down, the rabbit comes out again. There's quite a nice thing. What we're doing here when the rabbit moves to the tree is we're moving the rabbit and we're also scaling it down, which gives us quite a nice curve effect that looks like the rabbit's moving into the screen. But all it is just a move and a scale happening at the same time. So all we're doing is just layering those animations on top of each other over and over again. And that's how we do most of the things that we want to do in these games. So I'm not going to take you through building this whole game, but I want to show you just the first few steps so you can see how easy it is. So here I've got a completely new game. It's completely blank, nothing in there yet. So we'll add a trial, which is going to be the beginnings of what I was just showing you. And so the first thing we do is add a sprite. A sprite is just the game word for an image on the screen. This is going to be the tree, so we drag our tree image in. There it is. And now we can just pick it up and drag it around and resize it, just like I showed you in the task builder earlier. We can give it a better name. We're going to have two trees eventually, but we're just going to build the stuff on the right to start with. And now we're going to build our apple. So we want our apple texture to go in there. So again, we grab the apple image, push that in there, and good, that's huge. Let's make that a bit smaller, kind of put it where we want it. And now we're going to animate it. So we open up our animation tool. We're going to add a clip called appear. This is when the apple just appears. And we want to do two things. First of all, we want to just to sort of fade in, and we'll give that a little duration, just a short amount of time for it to fade in. And then we want just to move up in the air a little bit, just to kind of give us some movement and draw attention to it, so it's really, really stayed in. So we put those two things in there. We want to add another component just to make sure that the apple starts invisible and only shows when we animate it. And just for now, we'll just make that animation appear on the start. Obviously, later we'll make it appear after the rabbit's played. So now we play our little scene, and already we can see the animal appears and moves up a little bit. So that's how easy it is to just start putting these animations in, and from there we just keep doing more and more and more of those. So the rabbit is done in exactly the same way with a sprite and an animator, and adding in those different layers. The second big part of games that we want is the particle engine. Now, a particle system, we've seen quite a few of these in some of the previous demos. These are used for effects like fire, smoke, explosions, on all that kind of thing. And it's very simple. It's just a single image that keeps getting emitted from a central point. And you can control how many get emitted, how big they are, how fast they spin, and when they fade out. So here we have a nice little sort of constantly going puff of stars. If I want to go a bit faster, I can just make the speed a bit bigger. And now you can see they're slightly more effusive and they're going a bit further away. I can have more of them to make it a bit more intense. That's pretty wild. We can turn that back down again. And if I wanted it to be, and so that's one way of looking at it. If I wanted to do it slightly differently, I could bring the speed right down, but turn the duration up so they go slow, but they last a lot longer. And now you can see it's a much calmer sort of effect, but it's taking up that same amount of space. I can make them spin a lot more, and this gives more of a kind of a twinkling effect as opposed to the sort of explosion effect that we were seeing before. We could do a similar thing for smoke. This has got this same sort of idea, but this time we're using gravity to essentially suck the clouds upwards a bit, because that's obviously what smoke does. If I turn the gravity off, you'll see what it looks like normally. We're now just getting this sort of billowing out from a central point that we were doing before. But adding this sort of like reverse gravity, if you like, gives it this nice effect where the smoke's sort of going up. We make that a bit more intense. It now looks the smoke that might come out of a fire or something like that. So again, all of this is happening in real time. The full engine is running in there, and you can just simply keep tweaking these variables and seeing how they affect the particle system you're going into. You keep filling those until they look right. All right, so those are all possible in Game Builder, and I want to show you now a showcase of some of the simple things that you can do to build your games. So the first one is a rocket taking off. So this is just a simple case of animating things and layering things. So let's watch what happens. So our rocket stays there for a few seconds once we started playing, and then we see the smoke starts coming out, and then it takes off. Really, really simple. That is done. So we've got the sky is just the sky in the background. We've got our rocket frame, which is a container that allows us to animate one thing and essentially group a whole bunch of stuff underneath it. So the rocket there itself is the actual picture of the rocket, and the frame is the bit we're actually going to move around. And we want to do it like that because we've also got our smoke, So this is similar to the smoke effect I showed you before, but this time we want it to billow out downwards. And all we do for our rocket is in our animation, we have an initial delay, so we have a bit of a pause, and then we spawn our smoke and attach it to ourselves, and and that's how we make sure it's coming out the bottom of the rocket. Another little pause, and then we just move it up into the air, and that makes it take off. And if we watch that through again, we can see 1, 2, little pause, then the engine starts running, and then up it goes. Simple. The next one is, this was in one of the demos that Joe showed you, the cave opening. So I'm going to show you the effect, and then we'll show how it's put together. So this is the one with the cave with the treasure that we did. So what happens when you play it is that this sort of thing opens up and reveals the inside of the cave and reveals the treasure inside. The way that's done is by just layering up assets really cleverly. These are all of the art assets, so that row of 3 along the top that we're using to create this effect. So we've got a background, which is the one on the left. There's then a foreground, which is the one on the right. And there's finally a mask, that kind of jaggedy black outline. So when we layer them all up, we get what looks like this sort of combined cave. The black outline means we then can put black all around the edges, so we don't have any sort of edges of the screen that look a bit strange. But the key bit is that between those first 2 images, in between those 2, that's where we're going to put our door. I'm going to show you this again, but without the blacks around, so you can see how it's done. So here I've got the background and the foreground and the gem. So that one's there. That's got the main background. What we're going to do is add. I'm just going to use a simple quad for this, but obviously you could use an image with a nice kind of rocky texture. I'm just going to use just a grey square for this. And all we need to do is essentially, I'll make it a bit bigger so it's about the right size. It doesn't have to be perfect. And all we're going to do is just drag it into the right sort of order in the sequence. Obviously, don't put it right at the back, so maybe behind everything. We want it behind the foreground, but in front of the gem. Then we just add an animator. So this is the same animator we've been using throughout. And the animation itself is just a really simple move up in the air one. So all we want is a single option here to move to a position where it's going to move it up in the air again, give it a bit longer so it moves up a bit more slowly. And then when we play that, we can see the effect, and you can see the layering happening, right? You can see that thing having in between the 2. A good way to sort of imagine how to do this is just imagine you're making your game out of bits of cardboard, right? You would layer them up, and you would hold one in between 2 others and move it up and down to create these kind of effects. That's how it's done. In Katie's games, similarly, where you had the burglar moving off the side of the screen and some of those other kind of things, that's done in exactly the same way. We had the background, we had the burglar in front, and then we just had actually just a white panel on the side that the burglar moved behind to make it look like he was going off the side of the screen. The last one, this is one of my favorite effects, is how to make it look like a car is driving along a road. This again was in, I think, one of the ones that Joe showed you. The basic trick, and this is the biggest spoiler, is that the car isn't moving, the trees are. The car is staying exactly the same place, and all we do is simply move the trees down the screen. Again, the way we set this up, so we've got our tree here, and we've actually got 2 animations on this tree. We've got an initial one which just moves it to the bottom of the screen, and then it triggers an animation on itself. So one of the nice things about the animation tool is you can actually daisy chain animations together. And this second one, this repeat one, moves the top of the screen instantly, and then moves to the bottom of the screen in the space of a second in this case, and that one loops. With this other one, is doing exactly the same thing, except that initial one has got a slightly smaller duration because it starts further down the screen. We want them to line up eventually. So then that's how you create this effect. So again, it's just the trees moving down the screen, but obviously to us, when we look at it, it looks like the car is driving along. You can do the same trick. It doesn't have to be top down. You can do the same trick sideways, where you could have a car or a train or something puffing along, and all you do is just move the trees along in the background, but the actual train stays completely still. So that's my little showcase of things that you can do with the game builder. I hope that's given you some ideas of stuff that you might be able to do, and indeed gone like, oh, it's all just smoke and mirrors, it's all just clever tricks, there's nothing terrifying in there. And as I said, we are thrilled to see what people could build with it. We are running a grant for the game builder this year in conjunction with Dorothy Bishop. So this is called the Bishop Prize 2022. It's a prize for gamified research for PhDs and early career researchers using the game builder. All the details are there on the website. So if you're interested, do check it out and do consider applying.
Nick, that was fabulous. Thank you. There are some questions in the chat. One is, does this work on any browser?
Yes, yes, this is all completely running in JavaScript. So yes, it runs in all the browsers, and yes, it works on mobile ones as well. So obviously, if you're running on a tablet like Katie has, and indeed like Lucy has, then yeah, it all works absolutely seamlessly, behaves the same way across the board.
Yeah, and then another question is, can you use GIFs instead of images?
That's a good question. I haven't tried using a GIF. In theory, that should be possible, but I would need to have a go and check. Certainly there, when you do it, when you do that kind of thing with games normally, there's a similar but different way of doing that kind of animation. I don't know if they can accept GIFs for doing it. Normally you do what's called cell animation, where you have a picture which essentially has, say, a 4x4 grid of pictures that change over time, almost like a flick book, and it goes through those. But that's a good question. I will have to go and look.
Another question is, have we added eye tracking into Gamebuilder, and do we plan to add eye tracking into Gamebuilder? Is the eye tracking component in there?
We haven't integrated yet, but yes, absolutely, we intend to, and we should be able to. So the key thing with all of our new tools, so both the task builder that I showed earlier, the game builder we've seen just now, and indeed the questionnaire builder that we were talking about briefly as well, is they're all based on the same common core tech. They're not actually three completely distinct things that bear no relation to one another. There is a core layer that is common to all of them. So we are able to reuse some of these sort of more fundamental features like eye tracking or mouse tracking and things like that. We're able to use those across the board. The same goes for multiplayer, that at the moment we're trialing out in Task Builder, but there's no reason we can't. And we indeed fully intend to bring the multiplayer stuff over into the game builder as well. So yes, so one of our big kind of things we're trying to do here is make sure that all of those different things that people want to use can be used across the board. I don't know if anyone particularly has a burning desire to create a multiplayer questionnaire. That might be a bit wild, but in theory, that would be possible.
And then another question, have we added the drag and drop zones into Game Builder yet? The drag and drop components, are they in?
They're not in, but they're coming.
They're coming.
Yeah, they're in development. Yeah.
Helen, those are coming, and then you'd add that component to your image, and then it would be draggable and droppable. And then if you wanted to have a hot zone, and you drag the thing to the hot zone, and then when they collide, you'd add a collider, which would then trigger the particle effects, and then you'd get the reward image. That's how you daisy chain these things together. There's a question about whether this is separate to a normal subscription. So just in terms of pricing for the Game Builder is an add-on to your normal subscription. It meets all of our open science desires, so it's completely accessible within the tool. You can log into Gorilla today, click on the Game Builder menu, and you can use all of the tooling to create your game. The only thing you'll be prevented from doing is collecting data with it until you have a subscription. For that, you'll need to buy a subscription, and we can sell individual subscriptions, lab subscriptions and department level subscriptions, and you could have an individual subscription on your department license. That's all fine. So do get in touch if that is interesting to you. How are we doing on time, Claire? We've got a break coming up now, and then we'll be starting. We've got a break coming up in 5 minutes, and then we'll be starting again at 2:30. So we can hang around and talk about Game Builder a little bit longer. There was actually one further idea that I wanted to share, which I meant to share earlier and forgot for some reason. Can I share my screen, Nick?
Yeah, all yours.
Yeah. So one question I often get when I'm talking about gamification is, but what if the data is different? What if our lab-based task and our gamified version of the task give us different data? Can everybody see my screen?
Yeah, you're good.
And I think, yeah, but wouldn't that be interesting? Because if they're the same, that's interesting. That means that your task is robust to surface features. But if they're different, that's interesting, because it means your task isn't robust to the surface features. And if you created 3 different gamified versions with different surface features, which data would cluster together? And I think games can be a really interesting way of testing reproducibility and robustness of our paradigms to find out when does it look like the vanilla task that we're used to doing, and when does it not look like it, and where is it robust, and because after all, what we're really interested in doing is understanding human cognition in the real world, which is messy and complicated and all of those things. So maybe games are closer to being more ecologically valid. So it can also just be part of a journey. If you're a PhD student and you've run a task in Gorilla, there might be and you're into reproducibility as an idea, it might be interesting to take the task you've already got data for and go, what happens if I gamify it? Does changing the surface features mean I still get the same data, or is it different data? And would that open up more research questions for you? So that was just one idea I wanted to leave you with, is that one.